Okay, this is the schematic for the Tascam 424, specifically the preamp. I thought I'd just kind of walk through a little bit about how it works in the signal flow and how it might relate to that new stomp pedal that company came out with. I forget, the one that people are mentioning in the group. So if you don't know how to read a schematic, that's okay. I'll walk you through this and explain it as best I can in layman's terms. But basically, you would plug your guitar in here. This would be like your input jack. And then that signal then goes here, goes through a coupling capacitor into this first op amp. This is like, if you're familiar with a tube screamer, you know, the old ones had the coveted 4558 op amp. This is really similar. If you notice here it says U101A, that means that it's actually 1/2 of an op amp. So this first gain stage here, and if you look over at 101B, 101B must be for channel 2N, because you can see here 102B, 102A. So these two are actually the same op amp package with two different gain stages. Anyway, so signal comes into this op amp and is boosted by some degree. This resistor here, this capacitor, sets the fixed amount of gain for the op amp, and then coming out of that op amp, it goes into the trim control. So on the pedal, I think the pedal's got like an in, an out, a high, a low, and then the fader. So this input trim is going to be your in control most likely. From there, it comes out into like a switching matrix. This is basically telling the signal where you want to route it to. Position A sends the signal to tape. Pre-fader, I guess this would be tape pre-fade. B sends it to B, sets some kind of input pad, looks like, and then C is sending it to straight mic line signal, which is going to be into the rest of the preamp. So from here, the switching matrix, it goes into an EQ circuit. Looking at this topology here, this looks like a pretty classic textbook example of what's called a James, or sometimes referred to as a Baxandall EQ. There's actually a little bit of difference between those things. A James EQ is considered passive, meaning there's no op amps in the circuit to boost or cut. All of the EQing is happening passively. And if we look at the circuit here, there's no additional op amps in the actual EQ circuit. So it's what we would consider passive. So it's really more of a James, but in guitar land, the real common marketing term for this kind of thing is Baxandall, which it is, but it isn't, and I won't get into that. But so it goes into a basic high and low shelving EQ. So shelving EQ, basically, like, this is our frequency graph. If you boost the, we'll split the graph into lows and highs. So if you turn the high control up, what that does is at some fixed point, it raises all the high frequencies and it creates like a little shelf. And if you turn the high EQ down, it cuts that high band as kind of like a downward slope. Same for the lows. You turn the low frequency EQ knob up, at some point it raises all the lows above a fixed point. And then if you turn the lows down, it turns that down by a specific number of dB. So because this is passive, you lose a lot of signal just running through this, regardless of what your EQ settings are. So in order to make up for the lost gain from passing through this passive EQ circuit, there's a makeup gain stage here, which increases the gain coming out of the circuit. And then from there, and you see here this resistor capacitor here in this, what's called the negative feedback loop of this op amp, is setting a fixed amount of gain boost. The output of that is then coming up through this coupling capacitor into the input fader. So everything from this point back is all pre-fader. Goes into an input fader, typical 10K audio input fader. It's very common in pro audio, consumer audio. And then out of that, it goes into what looks like a buffer stage of some kind. It's another set of fixed gain, low impedance stage, specifically so it can drive the output of this preamp into multiple inputs. So from here, it goes to the pan pot where you could pan the signal left or right. So you can either go to the left bus or the right bus or a combination of. There's also a direct out. It goes to an effect send as well. So if you're going to send this to like a reverb or a delay. So this one signal is being sent to multiple outputs. And in order for that to happen without loss in fidelity, you have to have a buffer stage. So as far as the pedal's concerned, I think probably what's happening is obviously you're not sending to a pan pot or FX send or all that. It's a pedal. So probably the output knob is placed here. So like if we just kind of cut this section out, it probably goes to another little resistor or potentiometer. So, and that's effect out. So that pretty much describes how this works. As far as the uniqueness of the circuit, this is pretty textbook as far as analog input preamp and EQ go. There's a pretty famous Japanese textbook on EQ circuits and mic pre's and stuff. The name escapes me, but if you look through it, you'll see the exact circuit for a lot of classic Japanese recording equipment, mic pre's, tape recorders, things of that nature, and they all pretty much follow the topologies out of these books. And so as far as the design goes, this was all really meant to be low cost, low parts count way to take a instrument level signal or a line level signal and to EQ it and to send it to multiple outputs. So it wasn't, probably wasn't actually built much with tone in mind. It's built more for just, economy of scale. They've built thousands of these 424s. So if they keep the parts count low, then their profit margins will be high. And it just happens to have a cool sound, especially when you overdrive it. So if you look at your, where does the distortion occur? What may be a good question to ask here. So if your guitar signal comes in here and it's pretty low, you can then take the output of that and boost it into the EQ and then overdrive perhaps this gain stage or this gain stage, especially with the input fader. So I would have to guess that unless you slam the front end of the circuit with like a boost pedal or something like that, most of your overdrive is probably happening from this op amp stage right after the input fader, which would make sense, right? You turn the input fader up and you get nice crunchy distortion, or turn the trim control up, get nice crunchy distortion, and that's probably where the magic is. So anyway, I hope that helps explain and understand how the circuit works.